I'm going to do a couple of examples from homework number 3, section 3.2, measures of variation. I want to show how to do it on the calculator. They say that these data are the price of dollars to stay in a hotel. Find the range, variance, and standard deviation. First of all, the range is the highest value minus the lowest value. And I'm just going to eyeball these numbers. It looks like the highest one is 296 and the lowest one is 86. So to calculate the range, let me clear that. I'm going to go 296 minus 86. And that gives me a range of $210. So when I go back to the question, 210, it looks like they want units. The range is $210. Well done. Next part, the standard deviation. Okay, we're going to calculate the standard deviation using the calculator, entering the data into a list on the calculator, and I'm going to show how to do that. So I wrote down the data here on the paper on the side. So on the calculator, I'm going to enter the data into what's called list 1. So first I'm going to clear out whatever was already in list 1. So I'm going stat, and then number 4 there is clear list. So I arrowed down to clear list and hit enter. And if I now put L1 in there, and L1 is above the number 1, so I get second L1 and hit enter. Done. Okay, so list 1 is cleared. There may be something in the other list. I don't know. We'll see when we go there. But list 1 is clear. And now I'm going to enter those numbers into list 1. Stat, edit, and the first thing here is edit. So if I just hit enter, see there's some other junk in list 2 and list 3, but list 1 is clear. And I'm going to carefully enter the numbers on the list which I wrote down. 128 is the first number. 146 is the second number. 263 is the third number. 236 is the next number. 121, 86, 123, and 296. When you're entering a bunch of numbers in the calculator, I would always double check to make sure I didn't make a mistake. I'm looking now. Looks okay. So now that I have the numbers in here, I'm going to let the calculator calculate the standard deviation. If I hit stat and then arrow over to calc, the first thing is 1var stats, and that's what I want to calculate. So if I hit enter, now my stat wizard is off. I'll show you what happens if the stat wizard is on, but the list that I want to do these 1var stats on is list 1. So I'm going to enter list 1 here. And when I hit enter again, it spits out a bunch of information about these numbers. This first thing, x bar, that's the mean, but what I wanted, the standard deviation, that's a thing that's called SX. I'm going to write it down with all the decimal places, 78.0996387.4. Now let me just show you what happens if the stat wizard is on. So if I go to mode here, and then you see down towards the bottom, stat wizard's on, off. Mine is off right now. I'm going to turn it on just so you can see what can happen. Arrowing down to the stat wizard. Okay, so now I'm there. So now I'm going to click an on. So now it's on. Second, quit to get out of there. And now if I go stat, calc, 1var stats, you see it gives me a little menu. So it's asking me for the list, which is L1, so I'm going to leave that alone. This frequency list thing here, I don't want to have anything there. I'm going to leave that blank. And when I arrow down to calculate and hit enter, it spits out exactly the same numbers. There's the standard deviation, the 78.0996387.4. It's kind of 6 of one, half a dozen of the other, but now I can enter that number It was set, they want one decimal place, so to one decimal place, 78.1. And the units of standard deviation are the same units as the dollars. Check answer. Excellent. Okay. Now they want the variance. The variance is the square of the standard deviation. And I wrote down all those decimal digits because I want to square them all out to avoid a round off error. So going back to the calculator, I'm going to get out of here and I'm going to use all those digits which I wrote down, 78.09963,874, and that's the number I'm going to square to get the variance. So 6099.553571, 6099.553571. I think they wanted one decimal place, but let's check. I wrote down that number. So in the homework, the variance one decimal place, so to one decimal place, 6099.6, so 99.6. And then because we squared the standard deviation, the units of the variance would be in squared dollars, so it's that one. Let's check that. Good job. Let's see, how useful are the measures of variation if you're searching for a room? Let's see. They're very useful. They don't, who cares about the variation? Not very useful. Okay, here's what I think they're going for here. A person does not want to buy a room with a variation high, not very useful. The measures of variation are not very useful because when searching for a room, low prices, location, and good accommodations are more important than the amount of variation. I'm going to go with that. Nice work. Okay. Now, there's one more kind of question here that I want to go over. Let's see, this is question number 5. So this is the question about significantly high, significantly low, and what's called the range rule of thumb. So the range rule of thumb is that if a value is more than 2 standard deviations above the mean, it's significantly high. If it's more than 2 standard deviations below the mean, it's significantly low. So in this question, they give a mean of 74.6 and a standard deviation of 11.1. So to get significantly low values on the calculator, I'm going to go 74.6 minus 2 standard deviations, which was 11.1, 11.1, and that gives me the cutoff for significantly low values, 52.4. 52.4. Well done. For significantly high values, I'll add 2 standard deviations to the mean as follows. So it's going to be 74.6 plus 2 times 11.1, and that gives me a value of 96.8. 96.8. Check. Fantastic. And then what do they say? 66.8. Is it significantly high or significantly low? Well, to be significantly low, it would have to be less than 52.4, which it is not. To be significantly high, it would be more than 96.8, which it is significantly not. So it's not significantly low, it's not significantly high. It's neither because it is within 2 standard deviations of the mean. Good job.